Hi, everyone, and welcome to our second keynote talk today. And it's a pleasure to have Bob Cook today from Cambridge Quantum. Bob originally joined Cambridge Quantum as a senior scientific advisor with a focus on developing and building a leading quantum natural language processing, or QNLP, a capability, but now is the chief scientist leading a scientific team focused on applying their expertise towards artificial intelligence, including QNLP. Bob joined Cambridge Quantum from the University of Oxford, where he is right now, after a tenure of over 20 years where he was professor of quantum foundations, logic and structure since 2010. Thanks, Bob, for being here, and the floor is yours.
Thank you. So I'm going to start by sharing my screen. Share the screen. I now have to select the right screen, which is this one. Share. And I'm going to take this one and do full screen. Enter full screen. Brilliant. Okay. Okay. So yes, so I'm Bob. Like, I'm currently chief scientist at Cambridge Quantum Computing, right? But actually, some people, we are now kind of dropping the last name. And I was asked to address like my career path, roles relevant to CQC, and skills that get into quantum computing industry. And I will tell a story in which these three items are highly entangled. So about myself, so you know who's speaking. I'm fairly new to quantum industry. I only joined full-time like around New Year, which is sort of 6-ish months ago. Before that, as I was mentioned, I was a professor at University of Oxford. I mean, I'd been there for 20 years. I was a professor for some 10 years in a computer science department. And I'm bringing this story up because it's going to come back later. I've built a very big group there. We were like about 50 people, and all of these faces are going to come back later. So I just want to show this slide now with these people because a lot of them are going to come back later in the story. Right. So the thing which happens now is that after all my years in academia, I find some things here in industry I did many years ago at the university. And interestingly, at the time, when I was doing this part of academia, I found these things too academics, and even dare to say sometimes that these things will lead to nothing. So again, I will come back to that in my talk. So in particular, my talk will also address the flow of ideas between academia and industry, because I'm a person who's specifically well placed, I think, to talk about these things. Right. So I have two academic pasts, and one was in Foundations of Quantum. I mean, I've got actually more, but okay, let's focus on two. So one is in Foundations of Quantum Theory, and the other one was in Computer Science Logic. And in Foundations of Quantum Theory, we did some very, very foundational stuff. This was really about like an idea which goes back to Schrödinger from like almost 100 years ago, like 1935, so a little bit less. But he thought that fundamentally in nature, the whole is not the sum of the parts. And this is something which exact sciences didn't like very much for many different reasons. And one of the things I worked on was actually like making this like a fundamental part on how we think about quantum theory. Another thing I thought about a lot was computer science logic, and an issue here is that we don't interact with our iPhones in terms of whatever phone you have. I don't want to advertise one company here. We don't work in them in terms of bits. Like now, if you're even older than I am, and you played with computers, we were still actually programming with bits. I was actually not too much after the period that we were actually programming with bits. But obviously, you don't interact with your iPhones using bits. And this is a whole industry of like developing high-level languages to interact with stuff, and that's something I worked on too. Now, so the first thing, these Foundations of Quantum Theory stuff, which was very deep and very foundational, actually got me unemployed in the 90s. I was a theoretical physicist, and at the time, if you weren't doing the right theoretical physics, which was pretty much string theory at the time, then you couldn't get a job. And by moving to the second one, I actually got re-employed in 2000, which was at Oxford, where I then stayed for basically 20 years. So that was an important part of my career path. Now, interestingly enough, both the thing which got me out of a job and the thing which got me into a job, those two paths actually came together. They kind of became part of one and the same thing. So this all culminated in this sort of fairly recent book myself and a colleague wrote, which was Picturing Quantum Processes. Was a completely new way to think about quantum theory, like somewhat following Schrödinger's ideas. It's completely different from what anybody else was doing. And at the same time, this also provided a template to how to think about quantum theory in the same way as you think about programming your iPhone, basically, which is really just touching some buttons and touching some apps and stuff like that. But being actually expressive enough that you can actually do everything you can do with your usual quantum theoretical language and stuff like that. Okay, so let's sort of now start to intermingle the career path and the sort of stuff we did. So in 2004, I wrote one paper, and really that's the paper which made my career at Oxford, which was a particular paper which was called The Categorical Semantics of Quantum Protocol with Samson Abramsky, who's like a fellow of the Royal Society, which in the UK means like a very prestigious professor. And it was us together who then built out this big group I earlier showed. And there was like one kid which showed up like very early on, like 2001, 2002, a certain kid, Ross Duncan, showed up. That's him here. I mean, that's Ross, who was then the little kid, but here he is with my kid, my daughter, like they're messing around in my COVID hub, where I was, basically I gave a talk in this same event like a year ago, and then I was talking from my COVID hub, which is where Ross is now like dancing with my daughter. And so Ross has a background in CS, computer science. He was the first logic and quantum computer science PhD in the world. He did work in quantum foundations too, like the thing which got me fired. And now he's like one of the main people at CQ. He's the head of software in particular. He's the one who leads the ticket development, which is now, of course, a very important part of quantum industry. So the point which I want to make here is that if you come into the quantum industry, this is not a one-trick pony job. Like you basically have to be a little bit flexible. It's not. I mean, it's going to be about being adaptable because the thing is constantly changing. There's lots of duties which are, from my perspective, a little bit different than academia, and maybe not that much. You have to think about product development, business development, project management, PR, outreach, sales. But it's all just cool stuff. For somebody like me who spent his whole life in industry, I mean, I think it's cool to think about it. Well, I mean, I was also trying to be a rock star. I completely failed at that. And of course, we didn't think about these things. Otherwise, maybe we would have succeeded. I don't know. Right, let me continue here. Just checking the time because I'm trying to be a good student. So Rosa and I, we did something like in 2008, which was called the XCalculus. This was completely, I mean, maybe some of you may have heard about it. If not, just look it up. And you'll see it looks completely different than whatever quantum theory you would ever be taught at school, whatever linear algebra you would ever be taught at school. So we came from a perspective of quantum foundations. So basically, it was kind of like a little bit like, okay, what the language which people in quantum information processing use, which are like gates and logic gates and stuff like that, let's break them down in little pieces which we can much better play around with and work with, just like as if they are built out of Lego blocks. So that's the kind of thing we did. And as a result, like if you got a horrible matrix, like the one you see on the left here, you can actually draw it as something like the thing on the right, like the wires with the little dots. Now, if I ask you, like, look 3 seconds or 5 seconds or 10 seconds, whatever you want, on the right-hand side picture, close your eyes, write it down. Can you do it? Okay. Now look 3, 5, 10 seconds at the left-hand side matrix, close your eyes, write it down. I mean, you know the difference. And this is not just about writing down. This is about that the stuff on the right is much easier to remember. So that's something which came out of very foundational quantum reasoning. So we submitted that stuff at a time in 2008 to journals, and then the referee said, nice picture, so what? What can you do with it? Oh dear. Now this stuff is actually very fundamental in quantum industry. So it's actually, at the core of the best quantum compiler optimization. So quantum computers are quite small now. So if you want to do things efficiently, you have to come up with tricks to take like a program, which is usually a bunch of gates, and compress them as small as you can. And this sort of language, which people were actually borderline mocking at the time, is now basically the state of the art to actually do that stuff. So it's really important, like, not to believe in the hype or whatever, something like that, which is a very important thing if you're going to enter this industry. People now are using at Google, like, for surface code error correction. Qiskit, like, which of course is one of the dominant sort of voices in the whole quantum industry landscape. They're very keen on this XCalculus stuff, and they want to use it like as a basic tool in training quantum industry. And something else I'm going to talk about later is also kind of highly dependent on this. So here is an important lesson: the future can't be predicted. Future can't predict. You never know what's going to happen. We didn't know what's going to happen. And another thing is, like, revolution were never driven by the mainstream. Like, the ideas which are going to make a difference are the ones which probably will get a lot of opposition at some point. So it was the same with this kind of stuff we did. And in particular, I mean, this is even going a step further. Like, the coolest stuff happens when worlds collide. So this was a story from 2008. This is the XCalculus story. I recommend you all to look this up on the internet. There's lots of resources. It's a really cool thing, like to play with. It's like a fun game, but it actually then supports fundamental quantum technology. Now, in 2008, around the same time, there was a few people at Oxford too, like, one knew what is called grammar algebra, which is something you may associate with people like Chomsky. It's about structure of language and stuff like that. Now, everybody knows about machine learning, and the way in machine learning, you use neural networks where they represent meanings as vector spaces and do completely crazy stuff. And then at the time, there was a question: how can you combine, like, understanding grammar and this whole sort of new emerging vector space method? Sorry. Vector space methods for representing meanings. And basically, this came down to the question: why are there no dictionaries for sentences? How do you understand sentences when we understand the meaning of the words? And the answer actually came into this diagrammatic categorical quantum stuff. So at the time, we got a lot of sort of response from the media, because they started to call this stuff quantum linguistics and stuff like that. But there were no quantum computers around. So something we then did, well, I mean, this was like I'm not talking about Will Zhang, who was a PhD student of me at the time. We said, like, we actually should put this stuff on quantum computers whenever they came. Let me talk about Will Zhang, because we're talking about careers here. So he was a PhD student with me, with a background in physics. He was in the Oxford Blue Boat, and if you go in history of the Blue Boat races, he was in the Blue Boat when some swimmer swam as some protest in front of the Blue Boat. He did a PhD of computer science, and then he went to Rigetti, and now he's the head of quantum at Goldman Sachs, like doing quantum finance. And he also has this very nice company, which is non-profit, which is the Unitary Fund, which supports lots of quantum activities. So yes, just to give another quantum profile, at our end, like, basically, since this natural language stuff, like, became understood in terms of quantum, we said, okay, let's just figure out how we can stick it on quantum computers. First, we figured out the theory, then we did it, and then we just did it bigger. And so that's what we are doing now. And we are trying to go beyond natural language process on quantum. We basically going to take up the AI world. I mean, I'm now talking very ambitious here. But that's the sort of stuff we are doing. Like, we want to use quantum benefit to actually make AI better than it's now. I can't go into much details, but anyway. So we started a new team in Oxford. Like, this is really a new team. Like, it didn't exist a year and a half ago. Doing quantum natural language processing in Oxford. This office where I'm sitting, I basically moved in 2 months ago. It didn't exist. It was not a CQC office. Now it exists here. And the interesting thing is, like, loads of these people in this picture look in particular like this man, or like this guy who's like a big lead, or well, this guy we saw before from the picture of 2008, and these guys. If you go to this picture, You see them all here. This was at Oxford University. You see this person, you see, for example, these kids, you see him, which I pointed out. So all these people actually moved from academia to quantum industry, all of them. This one too, I can pick a lot more out. This one too, this one too. Lots of people from that picture from a couple of years ago, my group at university, have all now moved to industry. So I think that's, I mean, I'm sitting there, right? Some examples of people: Dimitri Katsaklis, long career in natural language processing, worked on Siri adaptable. He was the first one to test our language model. And is now leading software development and implementation in the team. Konstantinos Maganazidis, which I picked out in the picture, he has a condensed matter and tensor networks background, was prepared to learn category theory, now leading our hardware implementations and algorithms. I mean, 3 more people, like Anna did quantum foundations experiments at Oxford. Sarah was a pure mathematician. Richie did software and quantum machine learning. Steve Clark just straight came from DeepMind recently. So he was doing like DeepMind stuff. Right, some key observations. Foundational research has and will play a key role in quantum computing. There's no doubt about it. One finds academic features in all good quantum firms. That's just a fact. We don't know where we are going, yet so flexibility is the key. This is important for self-development. I mean, if you want to be a good scientist, like it's important to keep flexible, otherwise you're going to get bored. School never really ends. It's important for how you approach jobs, like an interview is like a date. When you have a date, you want to be flexible with the person you have a date with. It's the same thing with jobs. If it's not fun, nor gets you excited, just don't do it. That's pretty much the bottom line. I think I'm going to end here. Thank you.
That's the best advice ever. Yeah, if you don't like it, why should you apply for that job? It doesn't make sense, right?
yeah, I mean, yeah.
Correct. Great, thanks, Bob. So there are some questions. Joseph Achari Berada is asking, I work on machine learning, I lost it, and LNP, and I have background in quantum mechanics and skills in quantum computation. Can I apply to Cambridge Quantum?
I mean, of course. I mean, we've got a constantly running. I think I post this on Facebook and I post this on Twitter and stuff like that. We've got a constantly running application process where people can just apply all the time. I mean, everybody can apply, of course. Like but one has to explain carefully why you think you're going to make our team better.
That's a very good question. So, guys, you know what you have to answer. So, yeah, people with with computational chemistry and DFT background, if they can apply.
Yeah, there's lots of computational chemistry at CQC. Lots. There's actually now a new. So there is an existing team in Cambridge, but there is also going to be a new team in Munich.
Nice to know.
I don't know whether I was even allowed to say that, but well, I mean, it's too late now.
Amazing.
There's going to be a new team, and if you think you're really good, and you want the job, then you write to Henrik. Look him up. Henrik is going to be the head of the Munich team.
Great. So guys, go to the booth later and ask more about it if you want to work in Germany. This is amazing. And ask again if your background can be applied. I understand that any kind of background can be used in Cambridge Quantum, right?
And Henrik Dreyer just asked me literally this afternoon, hey Bob, how can I get a team together in Munich? Help me.
Amazing. I really want to ask you one question that I saw that, where is it? Have you had to pitch in front of investors? If yes, how was your first feedback about quantum computing from an investor without the background? I think it's a very cool question.
Can you ask it again?
Had to pitch in front of investors? And if yes, how was your first feedback about quantum computing from an investor without the background? This is a question from Alexandra Pinto.
I mean, that's a very good question. It's kind of very hard to answer it generically because there's very different type of people. You got the paranoid people and you got the enthusiastic people. But it's actually more like the sort of questions they ask can be very weird. Like it's quite, I can't say this. I shouldn't embarrass people here, but investors are weird people sometimes. They haven't got a clue what they're investing in. I'm going to be honest. Like, this for me a new world, but some of these investors don't have a clue whatever they're investing in. I'm going to be honest. Like, that's just the way it is. And so you get some really weird questions, and then this is not just about investors. I'm going to talk about, like, in my academic career, the same with, say, sort of military funders, and these people sometimes have no clue about science whatsoever, but they make big decisions.
Yeah, education is very important.
It's you have to. It's pure acting. But I'm lucky. I'm not the one who's doing that. Like, mostly. Of course, I talk to companies and potential collaborators and stuff like that. But usually, these people are very educated. They are usually so. We are now reaching to us. So we actually don't do that much, like at CQC, like relying on investment, like investors who don't have a clue about anything. We usually collaborate with, like, Honeywell, IBM. These people, they know what they're talking about. So it's a different strategy, like not to rely on venture capital.
Great. There are a lot of questions, so we stop here. I send you all the questions. Again, thanks a lot, Bob. Hope that people will talk to you later in the booth, and I'm going to jump into the next session. So thanks again a lot. I really enjoy your talks as usual, and see you soon. Bye.
Yes, can I just say, Chris just put a message like, Chris Griffiths, join our booth. Because there's a lot of questions about Hendrik Dreyer and stuff like that in his name. Just join Chris Griffith in the booth.
Perfect. There you go. Great.
Bye, everybody. Thanks for listening.